Hello everyone. So to recap, last time we were doing shadow map. Basically, we were just drawing to depth buffer the pedals, and now we can use that depth buffer as a shadow map. So that's what we're going to do this time. So it should be fairly straightforward, not that hard. So I'm going to explain what we're going to do in a second, but we have to make use of this depth shadow map slash in our shader. So let's do that, and we're also going to need information about well, basically the shadow projection matrix, which is from the shadow camera. So let's go to our material shader, and here I'm going to pick a new constant. So here it's actually float 4x4, and similar to projection view matrix, we're going to have a shadow projection view matrix, or better yet, better name might be light projection view matrix, because it's rendered from the point of light, and in our case it's directional light. So we're going to have that. If you remember last time, right, what we did is we had shadow shader, and then we used this, we had projection view, and we had also this idea of shadow camera, right, which we were using basically to create that depth texture. So it was something like this, maybe. So we rendered this, let's say that this is our pedal, then we had camera, and then basically we kinda just written all of this into our depth buffer. So let's go further. I explained that quickly. Let's see. In our material shader, we're going to need that, and we're going to need that depth texture, but we don't have to sample it as texture 2D. We can sample it as depth 2D of type float, and we can call it shadow depth texture. And usually we need sampler, but in this case we can just create sampler for ourselves in shader. So let's pass that information in, and then we can focus fully on just doing the lighting calculations. So in our render pipeline, let's do this. So here, render encoder set vertex buffer light camera dot buffer, and then we position 9. So we're going to paste that in here. Oh no, not here. My bad. Here, shadow camera. It's actually directional shadow. Let's call it shadow camera, even though it's kinda camera that's supposed to be light, but whatever. And then we're also going to need that depth texture, shadow depth texture, and here it's texture 2D, and we can paste it in here. Shadow depth texture, the texture at index 1. Cool. Cannot find. Again, I called it shadow camera. That's alright. So we're going to need to paste that information in pedal, and then in ball, and in floor. So let's do that. So we're going to have shadow camera, shadow texture. So let's do this. Shadow camera, shadow texture. I'm just going to copy paste this because it's going to be easier. So here as well. Not like that though. Here as well, and then we just say shadow camera, shadow texture, and for our floor as well. and in our coordinator we have to make use of that somewhere over here. Let's zoom in a bit. So we had ambient point lights. After the point light here we can say shadow camera and then shadow texture as well. Do it twice, of course. Oh, 4 times, not twice. And let's just see if it now builds. Gosh, now I have to unwrap. I hate that. Let's see. And it does work. Cool. So we can start with explaining how this is going to work, and roughly it's going to work something like this. Let's get this. So basically what we had is our first pass, and in first pass let's try to get this. So we had idea. Okay, this is not working. A second. So what we had in our first pass, if you remember, so basically we had this pedal, right? And then we said, okay, let's say, I'm just going to do it in 2D. We did it a bit differently, actually, but whatever. So we had this camera, and then we had basically parallel projection. So that means it's like this, like we send array, basically, which hits our depth information and then stores it in buffer, and here it overshoots, and in our depth buffer these values were usually white, right? And here in depth buffer usually we see something black because value might be something like 0.2, and that's true for every component of that buffer, right? Every pixel. So basically what we had is kinda like shadow texture, which I mentioned, but what it actually is just represents the depth, right, where it is from the camera. So in second pass we're going to make use of it. Let's say that now we're drawing our floor. So this will be our floor, and here this is our basically pedal, but here pedal is actually we will sample it from that depth texture, right? In our case depth texture looked something like this. So let's imagine that this is texture. We had here one pedal, and then we had second pedal, right? So this is depth texture, which is also our shadow texture, right? So what we're going to do is we're going to try to render one small, again with the same camera, right? So we're going to render this in our normal pass, right? We're going to have normal camera, but then again on top of that we're going to have this shadow light camera, whatever you want to call it, and then we're going to actually have, for example, we're going to be looking at some pixel, let's say fragment here, and then it has ray that passes through here, and actually it's more of a here, right? So we're going to sample this fragment. So as usual, we're just going to sample fragment like we did it previously, but then we also need to look into depth texture and see this depth here. So if this depth is kinda before this depth, right? If distance is smaller, we can say, okay, this region is actually in shadow, and we're just going to multiply our light calculations by some shadow value, and therefore we can say, okay, this is in shadow, and that's how it roughly works. So yeah, kind of terrible drawing. So we have this camera here. Then when we're rendering floor right now, so floor, we're rendering floor, but our pedal is in depth texture, right? So that's how it roughly works. So basically we just have to sample the depth texture. So let's do that step. First step that we actually need to do is to figure out how to sample the fragment. Let's say that when we're drawing floor, we need to sample it from the position of this shadow camera. So let's do that actually. That's the first step that we need to do, and then I'm going to get back and reference this terrible drawing that I did. So back in our shader, we actually need to sample that pixel. So we're going to do it like this. We're just going to have float I, and I'm going to call it frag position from shadow matrix, or you can call it fragment position, shadow view space, or whatever, right? It's not super important regarding the name. It might be just clearer, but I'm going to use this regardless. So how are we going to do that? So we can say frag position from shadow matrix. So previously we had this fragment position, and it was just model times this. So we can reuse that, and we can just say, okay, this is our light projection view matrix times float 4, and then this was x, y, and z, so this was vector 3. We can reuse it. So this is vector g or float g, and then we can just say this, and I think we're basically done here. So what do we have here actually? If I take a look at the drawing right now, let's say that we're drawing floor. So here, let's say that this is this pixel right on the floor. This is our floor, and we have this pixel because we use this camera, right? And then this the model, and it's in actually camera space, right? So that's good. It needs to be in camera space. Why? Because this is also in that camera space. Okay, so let's go further. So now we can actually we need to use that pixel, but we also need to sample from the that depth texture. So let's do that. So first thing that we need to do is I'm going to say here float 4. It might even be fine if it's 3, but I'm just going to call it what I'm going to call it. Let's think of the name. So maybe something like shadow projection coordinates. Its name is not super important. So what we need to do here is actually I'm going to use float 3, and what we need to do here is this. So in and then we do this x, y, z over in that. And why am I doing that? Well, if you remember, when we were doing basically the camera, and I was explaining the camera a bit, and also the projection, I mentioned that in our vertex stage, and this metal does for us, we have this part of a pipeline which divides everything with the latest, with the last basically a component of vector, which was usually this v. It was usually 1, but what's important is it does this perspective divide, and here the value is of course not going to be 1, right? It might be 1 here, but what's important is this light projection matrix actually modifies this double u value, and then it's different, and we need to do this perspective divide basically. Usually we don't do it simply because metal is going to do it for us on our position, but here we cannot, of course we cannot count on it. Then further, what I'm going to do is, because not now we need to sample that depth texture, so I'm going to do this shadow projection chords x, y, and now this is going to look weird, but I'm going to explain it in a second. So we have this shadow projection chords dot xy times 0.5 plus 0.5, and that's actually very simple. Why? So let's clear this so that I can explain it. So if you remember our what is it doing? I need freeform. All right, let's do it this way. So we have this texture, right? This is our depth texture, but its coordinate space is actually 0 to 1, right? But our space here, the metal one is going from -1 to 1, right? So we basically just need to convert from this space to this space, right? So that's what we're doing. If you multiply by 0.1, -1 to 1 becomes minus 0.5 plus 0.5, and then just by adding 0.5 it becomes 0 to 1. So we did that. One more thing that I'm going to need to do is simply to reverse this projection chord y is 1 minus this shadow projection chords y, because the texture is flipped. That's very common. Okay, now we finally need to sample it. So we can call this float shadow depth. And then what we need to do is, actually I haven't created a sampler. So here what we're getting is get a shadow projection coordinates so that we can sample a shadow texture. Alright, so here we're going to say sample shadow depth texture, and we can create a sampler here. Actually we don't have to do it, so I'm just going to say S for our sampler, and our sampler, let me take a look at the nodes, because these values are, we can just do it here. Filter, it can be nearest as well, but whatever. We can climb it to edge and less. So we have sampler. So now we need to sample it. Let's see how I sample texture. I forgot. We had it somewhere over here. Diffuse texture dot sample. Okay. So we need to do shadow depth texture dot sample S, and then we use these projection coordinates, shadow projection coordinates x, y, and that's it. So now we just need to do comparison. So also these projection coordinates. So let's get back to our drawing. So what do we also have from those projection coordinates, right? Well, we have this fragment here because we were sampling the fragment here. And now from the texture, we're getting actually the sample here, right? Let's say. So we have that information. So with that said, let's just compare them. And that should be very simple. Let's determine if in shadow. So we can say our float shadow by default is 0.1, and if shadow projection chords dot z is greater than shadow depth, we know that we're in shadow. Right? So basically this means no shadow, and this means in shadow. So we're going to multiply by it, and since it's 0, we're not going to have any light. So what's we're comparing here, right? Well, it's this what I mentioned here, right? We're comparing the z of this, right? We moved everything to clip space, right? If you remember clip space, so we have our screen, we have -1 to 1, and then we also have some depth, right? -1 to 1, our clip space, and we also have our depth, which is usually going to 0 to 1, right? And we're comparing the depth from this texture. So we got this, we got this. If this is less than this, or if this one is greater, we know that we're in shadow. So let's see now. Further, we just need to multiply everything. I'm not going to do ambient light. Ambient light is probably fine if we leave it. We just want to have some ambient light. But here we can do times shadow. Here we can do times shadow. That covers our directional, spectral, and diffuse light. Here, let's do this as well. And here, let's do this as well. Let's try it. Maybe it will even run correctly. Open anyway, and it works. Right. Although I did move a bit because I was also preparing for this. I did move floor a bit, so if it doesn't work for you, just try to move floor like 5-10 units to the back or something like that. For example, for me it's 5, and if I run it, it actually works. We have shadows. So just with shadows, one more thing which I haven't explained is actually there is sometimes an issue with shadow, which is kind of you have this pixelated look of shadows. We don't have that issue, so I'm not going to try to fix it. But usually you just need some kind of a bias for shadow, because when you're sampling, the texture might not be perfect, and then you might get these imperfections, which are usually just, it's going to look kind of pixelated. You're going to have some white, some black regions. Here for us it's perfectly fine, so nothing to fix. But if you do experience it, I just try to Google for it, and you're going to find solution. It's pretty simple. So that should be it. In our case it works fine. So what to do is maybe just a recap. So basically what it boils down is we kind of had to render our scene. Maybe I should do it once more so that we can just recap real quick here. But what we had to do is, first we had this idea of having well, basically we had to create some kind of camera for our lights, right? And then we were rendering scene from the point of view of our light, right? And then we were getting the shadow texture, right? So let's say this is our pedal and it's somewhere here, and then we also get the other one. So we got the shadow texture, or depth texture, right? This is actually just information about the depth of our objects, and we were rendering just pedals. So I forgot to do this small cube. We can do that next time, it's not super important. And we rendered that. Then in our second phase, when we were rendering material, let's say that we were rendering floor, because the floor is the most obvious one, it will receive the shadows. We were using that, but we also had to sample this texture, right? And this is the sample from the texture, this thing. So we were rendering once again from the, well, we were rendering as usual, but we also had a small code that took this basically light camera or shadow camera, whatever you want to call it, and we took this sample, and then we took the sample, let's make it a bit clearer, from the floor, right? And then we just compared this sample, and if this sample is closer or its value is smaller than this one, we were basically saying, okay, here we are in shadow in this sample. So we did it for the bunch of the samples, right? So we will compare here, everywhere basically, and then we can determine, okay, this is in shadow. That's roughly how it works. So with that said, for the next time, since we have shadows now, we just need to do basically some gameplay so that this thing is moving, right? This ball, which I call it, even though ball might not be the best name, but basically we just need to collide it here. That's the next step, and then we just have to do basically what I'm going to do is try to create a split screen gameplay so that you can play with someone with basically the horizontal split screen. So I'm going to do that next time or the time after, and that's it for this video. If you enjoyed it, please like, subscribe, maybe leave a comment, and until next time.